Alright, so for this lesson we're going to focus on what is a line. Last lesson we looked at what a point is. Right off the bat, we're just going to define, we talked about what a single point is. Just imagine if you put another point somewhere else. The only real thing that could connect those is what we call a line, and notice that it goes in either direction. 2 points are connected by a line. Just like a point, I misspelled that, I should say like, let's fix that real quick. No pun intended. Just like a point, a line can be as thin as possible, or infinitesimally thin. In other words, a line has no actual width, it is merely a concept that connects 2 points. So how far can the line go? In fact, it goes on forever in either direction. So I want to kind of address both those things as we look at our line here. You can imagine that this has a certain width to it when we draw it, but the actual concept of a line does have no width. It's just basically whatever connects these 2 points, whatever that may be, just a concept, has no width. And again, like we said before, it goes in either direction forever, which is kind of crazy. I've always kind of thought about the universe. Does the universe have any boundaries? Does it have an end? Well, if a line goes on forever, actually, then that would mean it's limitless, right? Like there's no end to it. It's just crazy to think about sometimes what could be out there. So a line goes on forever, which is pretty cool. A connecting line that ends at both points is called a line segment. Okay, so we have 2 points here. If we imagine just what's in between them and at the points, that would be considered a line segment. Okay, then we have what's called a ray. And a ray starts at a single point and goes on forever, so it's somewhere between a line segment and a line. Okay, it's a line that connects 2 points and stops at one of them. Pretty simple, right? So that's kind of like the 3 types of lines that we study. A line, goes on forever, a segment, and a ray. And the way we name lines, we name them by the points that they connect. So points usually have names, right? A lot of times capital A and capital B. So this particular line, we could either call BA or AB. It doesn't actually matter which point you choose first, because it's the same line, right? Now when you get into what's the word I'm looking for? When you get into vectors, okay, it does matter. A vector has direction, but a line really doesn't, because it goes both ways. So this would be called AB, and we typically draw the actual line symbol above those 2 points to denote the fact that it's the line that goes through AB. Just like if you had, let's say, a point, let's say you were connecting a line between Paris and London. You could call it the London-Paris line. Let's say there was a train going from both of them. I don't know. I've never actually been to either of those cities. But let's say there was a train that took you directly from Paris to London. It would have to go through the English Channel or under it or on a bridge or something. But that would be called the Paris-London line, right? It'd go straight from one to the other, and you would call the line by the 2 points it connected. Same concept here. You call a line by the 2 points that connects them. We draw a line above the 2 points to explain it is a line. A couple more things to note. If we just draw a little segment above it, then that would signify it's a line segment. And if we just draw a ray above it, that would signify that it's a ray. So you can either have a ray, a segment, you can have the ray AB, you can have the segment AB, or you can have the line AB. Some practical examples I thought of as far as an actual line would be the timeline. Okay, I personally don't believe that there really is a beginning to time, and that's just my personal opinion. We say, okay, well, the Big Bang, blah, 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 blah. Okay, I'm not arguing that there wasn't a Big Bang, but to me, I've always just thought there had to be something before that. Maybe it was another universe, whatever. Something was before there. So a timeline is a good example, because no one really knows when time began anyways. So to me, I just think it goes all the way to the left, it goes forever. And certainly, the future is very uncertain, so we can't really say it's a ray where it stops. So a timeline is a good example of an actual line. Here we just have some various silly things on the timeline, but historical things. But the point is, things always, there's a lot of things that came before us, there's a lot of things still to come. Other than that, it's very hard to imagine other practical examples of a line. I was asking my students, and it was very hard for us to come up with one. So if you have one, let me know. I'd be happy to I'd be happy to know what your inputs are on that. Maybe like when the sun shines, it kind of sends rays in both ways. And I think light actually travels forever, kind of like sound. But anyways, that might be another one. A segment I thought of was something that I found online. Here's where I found it. It said it was I could use it as long as I gave a link to it. So here it is. I did not come up with this illustration, but it's a hammer. Whoever drew it did a good job. And it's a segment, right? Because it has a start and an end, just like basically any tool. That's an example of a segment. A lot of things in the world are segments because it has a beginning and an end. And then a light, if you had a flashlight, which they call a torch in South Africa, if you have a flashlight, it starts at a single point and goes on forever, apparently. That would be considered a ray. And again, this is free stock photo that I found. Here's the link to it. Whoever did this flashlight did a great job. Okay, so this says graph these 2 points, which we learned in the previous lesson, and then graph the line segment AB. We know it's a line segment because of the symbol right here. So we've already done that, and I'm just going to kind of go through and show you what we did. So the point 24 would be right here. Okay, and then the point negative, why is this not working? Negative 7, 1 would be right here. And just connecting them with the segment would look like this. Now this is a little thick, so I want to do it again myself. Look closer to this. It doesn't have to be that thick. And that would be our line segment. Having trouble here. That would be our line segment AB, and I didn't label these, so I might as well go ahead and label them. The first point that we drew was A, and the second one B. And we connected them with a segment. So this would be segment AB. And I'll even label that as well. So this is segment AB. And that's it. That's how you draw a line segment or a line or whatever. Okay, next we have the point 0, 0 and B for A. B is 4, 8. We're going to graph. Now this is line, right? Because it goes both directions. So first of all, the point 0, 0 is the origin, which is down here. Then the point 4, 8 is right here. When you connect them with the line, you just draw a line and draw arrows in both ways. And again, that would give us the line AB going in both directions. And it goes on forever and ever and ever. Okay, next we have the point 2, 4, and for P and Q equals negative 7, 1. Sometimes we use Q and P for points. This is particularly asking us to sketch a ray because it starts in one place and goes on forever. So the point 2, 4 is P. It's going to be right here. And the point negative 7, 1 is going to be right here. Now this is kind of an important example, and again that was too thick, so I'm going to change that. Notice that Q comes first and then P. So that means our ray starts at Q and goes through P and goes on forever. It would be different if I started at P, for example, and went through Q and went on forever. But again, Q starts first in our expression, so our ray is going to start at Q. And it's just going to go, that wasn't quite right, let's try this again. It's going to go just like this. And that's going to be, again, that's going to be our ray, QP, just like that. Very good. Now let's graph the points 2.5, 7 and pi, negative 4.5. So R is 2.57, S is pi, negative 4.5, and again we're going to graph a line on our 7. So first of all, 2.5, 7 is going to go right here, somewhere between 2 and 3 for X, and 7 for Y. And then pi, negative 4.5 seems peculiar. Pi is 3.14, so somewhere about right here. and then it says negative 4.5. So I'm just giving you something that you could see. One day you might have to graph something that's pi comma negative 4.5. And again, pi is somewhere a little bit past 3 at 3.14 for your x value. Then you just connect them with a line. And this one we kind of have to zoom back and forth so we can see the whole thing. But it would look like that. Okay, that would be the line that would connect those two. And that would be our line RS. That's it for this lesson. We have identified what a line is. It does not have a particular particular width. It's a concept that connects 2 points and goes on forever. Then we have a line segment, and finally a ray. If you have any other questions about what a line is, or any of these other concepts we talked about in this lesson, let me know.